Yeah, today we are going to discuss the paper what you have written, that is SB1 dated 23/10/2018. So starting with question number 31. Which of the following layer pattern will have a void fraction of 0.26? Void fraction 0.26 mean packing density is 0.74, that is 34% is occupied by the atoms. So this is either HCP or CCP. In HCP, we have the second layer pattern repeating. While in CCP, we have the third layer pattern repeating. So it should be ABC, ABC, ABC. That will be option number 2. Going to question number 32. The binary solid has atoms B constituting FCC lattice and atoms A occupying 25% of the tetraholes. What will be the formula of the solid? Since B is in FCC lattice, number of atoms of B will be equivalent to 1 by 8 into 8 plus 1 by 2 into 6, that is 4. Total tetravoids available are 8, out of which 25% are occupied. Thus, atoms of A will be 1 by 4 into 8, that is 2. Thus, formula is A2B4 or AB2. Going to question number 33, which has only one Bravais lattice. So it should be hexagonal, because in hexagonal there will be only primitive, while in cubic we have 3 primitive, FCC and BCC. In tetragonal we have 2, that is primitive and BCC. In monoclinic we have 4, that is primitive, FCC, BCC and ECC. Going to question number 34. In zinc-blende structures, Zl plus rho ions are in alternate tetrahedral voids and S-2 in CCP lattice. So S-2 in CCP lattice. So that will be 1 by 8 into 8 plus 1 by 2 into 6, which will be 4. Tetravoids available are 8, and alternate voids are occupied. Thus, 4 are occupied. So coordination number is 4:4. Thus it will be the fourth option. Then 36, which is incorrect. See, high pressure always favors an increase in coordination number, while high temperature favors a decrease in coordination number. So, if pressure is increased, there should be an increase in coordination number. Thus, third option will be incorrect. Moving to question number 37. An element with atomic mass 50 having FCC structure has edge length 400 picometers, the density of the element. So first let us put the formula. B is equivalent to mz by n naught a cube. Now the data given is m is equivalent to 50. Since it is FCC, z is 4. N naught will be 6.023 into 10 to the power of 23. And edge length is given 400 picometers. That will be 400 into 10 to the power of minus 12 meters, or 4 into 10 to the power of minus 8 centimeters. Therefore, D is equivalent to 50 into 4 by 6.023 into 10 to the power 23 into 64 into 10 to the power of minus 24. So that comes to be 5.18 gram per cc. So moving to question number 38. In a crystalline solid, anion B is arranged in CCP lattice and cation A are equally distributed between octa and tetravoids. See, if all the octavoids are occupied, the formula of the solid is. So first let us take atoms of B. So that will be 1 by 8 into 8 plus 1 by 2 into 6. There will be 4. Okay. Then cation A is equally distributed between octa and tetravoids. Okay. Octavoids available will be 4, while tetravoids available will be 8. Okay. Since all the octavoids are occupied, the formula of the solid is, so it will be 1 by 2 into 8 plus 4 will be the number of atoms of A. So it should be A8, B4 or A to B. Moving to question number 39. Which has highest number of formula units per unit cell? In all, we have 4 formula units, that is in NaCl, then Na2O, which is anti-fluoride type, and CaF2, which is fluoride type. So thus answer is all. 40th, density of the crystal in density will be decreasing in Schottky defect because equal number of atoms will be missing from the crystal lattice. Going to question number 41. Zinc sulfide has two different structural forms, zinc blende and woodsite. What will be the coordination number of cation and anion? So coordination number of both cation and anion will be 4 and 4 in both of them. So that is option number 2. Then tetravoid is surrounded by 4 atoms. In the given figure, which are the numbered atoms? See, tetravoid will be along the body diagonal. 2 tetravoids will be on the body diagonal. Okay. So these will be surrounded by the face-centered atoms and the corner atom. Thus, it should be 1, 2, 3, 4. That is option 3. Then, moving to 43, which is a covalent solid, silicon carbide or carborundum, that can be considered as a covalent solid or a network solid. Then, moving to question number 44. What type of defects are given in the figure? So just look into the figure over there and count the number of cations and the number of anions. So anions are with the darker shade, and if we count the number of cations, they are 8. And counting the number of anions, they are only 7. So it should be a metal excess defect. Okay. So moving to question number 45. Unit cell edge length of NaCl is given as 600 picometers. Then the density will be, so in NaCl there will be 4 formula units per unit cell, and edge length is given 600 picometers. So let us put the formula B equal to mz by n naught a cube. So m is 58.5, that is 23 plus 35.5 for NaCl. Z is 4, N naught 6.02 into 10 to the power of 23, and edge length A is given 600 picometers, that will be 600 into 10 to the power of minus 12 meters, or 6 into 10 to the power of minus 8 centimeters. So substituting in the formula, B equivalent to 58.5 into 4 by 6.02 into 10 power 23 into 216 into 10 to the power of minus 24. So this comes to be 1.79 gram per cc. Okay. So moving to question number 46. Cesium bromide has a cubic structure with edge length 4.3 angstrom, shortest interionic distance between CS plus and Br minus. So shortest interionic distance is nothing but Rc plus Ra. So in DCC RC plus RA will be equal to root 3 A by 2. So given the electrolyte 4.3 angstrom, therefore root 3 into 4.3 by 2, that is 1.732 into 4.3 by 2. So this comes to be 3.72 angstrom. So going to question number 47. Lithium crystallizes in BCC lattice. You are asked how many next to nearest neighbors does lithium has. See, in BCC, nearest neighbors will be 8. Next nearest neighbors will be 6. Moving to 48. The ionic radii of Rb plus and I minus are given 1.46 and 2.16 angstrom. The type of crystal structure. See, whenever cation and anion radii are given, calculate Rc by Ra. That is, cation to anion radius ratio is calculated. So Rc by Ra. So that is nothing but Rb plus by Ri minus. So this will be 1.46 by 2.16. So this is coming to be 0.68. Now let us correlate. If Rc by Ra is in the range of 0.414 to 0.732, it is FCC or NaCl type. So it should be option number 2. Moving to question number 49. In a compound XY2O4, oxide ions are in CCP lattice. So let us first count the oxide ions. So O minus 2 ions will be 1 by 8 into 8 plus 1 by 2 into 6, that will be 4. Then cation X are present in octavoids and Y equally distributed between octa and tetravoids. The fraction of the octavoids occupied, that is what we are asked. Okay. So first let us see total octavoids will be 4 and total tetravoids will be 8. Now it is given X is occupying octavoids and Y equally distributed between octa and tetra. Therefore, X in octavoid, Y in octavoid and tetravoid. Thus, octavoids occupied are 2. Therefore, fraction of octavoids occupied will be 2 by 4, that is half. Then, moving to question number 50. Metallic gold crystallizes in FCC So closest distance between atoms will be 2r. Okay. And for FCC, r equal to a by 2 root 2 or 2r equal to a by root 2. So 4.07 by 1.414, this comes to be 2.87 angstrom. That is option number 1. Moving to question number 51. Nickel oxide is having a formula Ni 0.980. What fraction of nickel exists as Ni plus 3? So let Ni plus 3 be X, since total nickel is 0.98, Ni plus 2 will be 0.98 minus X. Since solid is electrically neutral, charge on cation should be equal to the charge on anion in magnitude. Therefore, 3x plus 2 into 0.98 minus x equal to 2. So 3x plus 1.96 minus 2x equal to 2. So x equal to 0.04. Therefore, fraction of Ni plus 3 will be 0.04 by 0.98. The percentage of Ni plus 3 will be 0.04 by 0.98 into 100. So this comes to be 4.08%. Moving to question number 52, which is a natural polymer. So cellulose is a natural polymer, while monoirs, nylon 66, they are all synthetic polymers. Then moving to question number 53, which is a cross-linked polymer. So cross-linked polymer will be bakelite. That is option number 2, which is obtained from phenol and formaldehyde. Then question number 54, which is not correctly matched. So it should be first option, because neoprene is a polymer of chloroprene. Chloroprene is 2-chloro-1,3-butadiene. So first one is not a correct match. So moving to question number 55. So the given polymer is it should be a copolymer, because if you look into the structures of the monomers from which it is formed, so the monomers can be like this: NH2, CH2, 6NH2 and COOH CH2 8COOH. So the monomers are hexamethylene diamine and decandioic acid. So it is a condensation copolymer. So option 2 should be right. Moving to question number 56. Which of the following set contains only copolymers? So copolymers should be obtained from two different monomers. So it should be option 3, because Bunayas is obtained from styrene and 1,3-butadiene. Nylon 6,6 is obtained from hexamethylene diamine and adipic acid. Okay. And also glucan. Moving to question number 57. Bakelite is a product formed from. It is obtained from phenol and formaldehyde. So it should be option number 1. So question number 58. Which of the following polymer is prepared from caprolactam? Caprolactam is the monomer for nylon 6. So it should be the third option. Then moving to question number 59. So we are given some polymers and we are asked to arrange in the increasing order of intermolecular forces. See, the intermolecular forces will be in the order rubber less than plastic less than fiber. This is the order of intermolecular forces. So if we classify, A is given nylon 6, which is a fiber. B is given Bunayas, which is a rubber. C is given polythene, which is a plastic. Therefore, order will be B, C, A. Moving to the last one, question number 60. The monomeric units of PHBB. See, PHBB is a biodegradable polymer prepared from 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. So that should